Oh my gosh, this statistics is like killing my brain. I need to have a better attitude about it. Like I feel like I feel like I don't know anything. I'm just guessing all the time.
Don't feel bad. I feel like that too half of the time.
I know, it's just ridiculous. 0.00312. Let me see if I can get her on here again. I'll add her again. It's weird because her name doesn't come up till I start typing her whole address in. Let's see. So I got 0.312 times 0.845 equals, did you get 0.003 if you round?
No. I think we all
You
got
didn't?
different answers. That is so weird. I can't get Michelle in this call.
Okay. Let me see. For some reason, her name. Where is she? I'm trying to call her one more time. Oh, and then yeah.
Oh, there she is.
Oh, there she is. Okay.
Okay, I don't know what happened.
I know all of a sudden you guys were gone. Like I could see you, but no one could hear me.
Right.
So, Michelle, what did you get for that question that we were doing?
Like, I got the wrong answer on it. So let
I
me
got
try it one more time.
0.003.
I keep getting 0.0472.
Okay, so are you taking 0.75 times 1 minus 0.75?
I thought we were doing 0.845 times the square root of 0.75 parentheses 1 minus 0.75 divided by 60.
Yeah, that's right. But you have to start. Oh, you know what I didn't do? I didn't do my square root. That's why. Okay, I keep forgetting the square root.
I got
You have to
point
start with the
zero
square
four
root.
seven.
Yay! Okay, that's what I got.
Okay,
Okay.
let me try it. I didn't do my square root.
Are you recording this again, Michelle or
Yeah.
Monique?
Yes.
So I only have like 2 more minutes and I have to go, and I'm already over my time.
Oh no.
I keep forgetting my square root. That is my problem. Times 0.845 equals. You got 0.047?
Yep.
Okay, that's exactly what I got. When I do my square root, it works out. Okay, so then we have the lower bound is 0.640 and our higher bound at 0.860, right?
Yeah.
And then if you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval? When we increase our sample size, don't we always get a bigger
Confidence interval.
Yeah, that's what I'm wondering. Because I think that's what my notes say, right?
Is it only the margin of error that decreases when you get a big sample size? I don't remember.
It says as the level of confidence increases, the width of the confidence interval increases.
So say that one more time. If the what?
As the level of confidence increases, the width of the confidence increases. As sample size increases, the width of the confidence interval decreases.
Okay.
So as the sample size increases, in this case, it would
Uh-huh.
decrease.
It would decrease.
Unless in this reading you read something different.
No, I think that's right.
No, I think that's right. That was from the first chapter, right? That we just did.
Yeah.
From
Uh-huh.
the other day.
To conduct a hypothesis test on number 11 for one portion, two requirements must be met. Suppose P equals 1/2, 0.50. What is the smallest n can be and both requirements still met? Okay, so I don't know how we figured that out in the other chapter, but we figured it out to be 40. 1/4 equals, you would say 40 had to be the smallest.
Mm-hmm. Yeah. Let me go back to
And then,
that.
and then I got it wrong on this quiz here that I just took, my homework quiz,
Uh-huh.
because it said 1/10, and so I put let's see, I don't know if it said one quit. What did it say?
1/10, like 100 or something. I think I
Yeah.
put that in the review.
No, I put, oh no, I did get it right. If P is equal to 4/5, what is the smallest value? And I put 50. So I guess I did get it right. So then in
Was it
this
20?
case, it would be 20, wouldn't
Yeah, I
it?
think that's what I kind of picked up from the last time we did that, and then in the review, I think it had like 1/10, and the end was 100.
Yeah,
So I
yeah,
was wondering if they just like add a 0 to the
yeah, that's what I'm
denominator.
guessing. Which, oh, but then, yeah, and then the next one is to conduct a hypothesis test for one portion, two requirements must be met. Suppose P is equal to 1/10. What is the smallest n can be, and both requirements still be met? 100. Is that the same for this one?
Okay, wait. Go back to number 11 and tell me what answer did you get for 11?
20.
Why did you get 20?
Because in our last group quiz, when we put a 0 behind the bottom number, 40.
Yeah, I remember it was like 1/4, and we put
Yeah,
4, and
right.
we put 10, and it wasn't right, and then you put 40, and it was right.
Yeah, and then I did it in my group, my homework quiz just now, and I got it right because it says if P is equal to 4/5, what is the smallest value of n that satisfies the requirements for normally distributed? And I put 50, and I got it right.
Okay.
However, that's not asking
Okay.
the same question. It's asking what is the smallest for both requirements for the hypothesis test. And I don't remember reading anything different, but I could have. I just don't remember. But it seems like I read like you did in this one, Lupita, that they put a 100. They made, if
Yeah,
it's
I
1/10.
remember
Yeah.
1/10 equals 100. I think it was in the reading.
Yeah, I remember reading that too somewhere.
So you're saying 12 is 100.
No, I'm saying, yes. I'm saying 12 is 100 and 11 is 20. But I don't know. Because the question might be different because it's different than the one that was on the quiz. So I'm going to go with those for now, and then we'll see what happens.
Okay.
So then, for the water quality study in reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using the significance level of 0.05 with the following hypothesis. P is equal to 0.6 or P is less than 0.6. They collect new data and this time N equals 80 and X is equal to 38. Indicate good health. The conditions for conducting a hypothesis test are satisfied.
So for that one, that's the one we do N times P, and it has to be less than or equal to 10, right?
Yes.
I mean, greater than or equal to.
We have to do both those equations, right?
Yeah.
For the hypothesis.
And that's
So-
my guess, but I got it wrong on the homework. So I don't know.
N times P is greater than or equal to 10. And then the other one is, can't remember off the top. N times
1 minus P.
1 minus P is greater than or less equal to 10. Okay, and so P equals 38 over 80, right?
Yeah.
.475.
Mm-hmm.
Okay.
I got 38 and 42.
Okay, 38. I got 38. Then 80 times 1 minus 42. Okay. So I'd say the answer is yes.
Mm-hmm.
Monique, did you get that?
I'm still working on it. Hang on.
Okay.
Okay, and then I'm just doing one more. Hang on just a second. And I would say yes too. Because I got 42 and 38 and they're both
Yeah.
greater, right?
Mm-hmm.
Okay.
And then for 16, it's going to be 0.475, right? Because that's where we did the 38 divided by 80.
Yep. That's
Right.
what I 0.475. And then 15
Number
find
15.
a statistic.
So in X, I put in 38. And in N, I put in 80.
Uh-huh.
It says my test statistic is minus or negative 4.392.
Negative
4.392.
4.392. Okay.
And the next question is the p-value.
P-value, it says 0.000.
Okay.
Okay, and I
And
gotta
then-
get back over to my quiz here. So
So it's
type in my answer.
0.00 and it's less than 0.05. So we're going to reject the null
Yeah.
because it's less than, right?
I think that's right.
And there's sufficient evidence to conclude that the water quality in the area has not decreased. Our question was what?
Is that B?
Has decreased. There is sufficient evidence that it has decreased, is
Okay,
what
for
it should
number
say.
7, I turned in my quiz already.
Uh-huh.
Number 7, it says we have it wrong.
Okay.
And then 15 and 16, it says that we have it wrong. And then 18, I put B, but it's not B, so that one's also wrong.
Okay.
18 should be D, I think. It's
Yeah, I
D.
think it's D.
It's D.
Okay.
But
Well, I have to go because I'm
okay.
like way over my time.
All right.
But thanks, ladies.
Thank you.
Okay,
Bye.
so what I think we need to do is take the X and minus the lower bond to get that number to determine the margin of error. Because remember how Abby did that before?
Okay. Yes, I remember how she did that.
Okay, so let's try that. So the X would be in this case, is it 45? 45.
45.
So I'm going to minus 45. And she did do the lower one, right?
Yeah.
Okay, so I'm going to take 45 minus 0.64 equals, wait, is that 0.64? Yeah, 45 minus 4 equals 44.36. I'm going to put
Okay.
that as my answer.
Okay.
Okay. And
On
then,
number 7.
yeah, on number 7. And then what did she say we got wrong? Oh, the p-value.
24.36.
We got the no, we got the number 16 wrong, the p-value on 16 wrong. Do you
She
have to
said we
double?
also got 15 wrong.
We did.
I thought she said 15 and 16.
I swear. Okay.
I'm
So
wondering if we're not supposed to put in X up in this other thing. Right here. 38 is our X.
Mm-hmm.
N is 80.
Uh-huh.
We want the 95 percentile.
Yes.
So then it says Z is negative 4.392.
Uh-huh. But the p-value, do you double click on that or anything? You can't double click on it, can you?
No.
Okay, so let's look. What are we asking here? Let's see. Well, X over N equals the P with the hat. So 38 over 80. Yeah, that's right. Right?
Yeah.
I think we got that one right.
Number 15.
0.475. Yeah, I think we got 14 right. Then, so we do 0.475. Then we're asking find the test statistic.
Yep.
Yeah, so you would go in and you'd put it in that thing.
Yeah.
Is there anything else? Bring that up. Bring up your thing there.
It is up. It's right here. Am I not
Yeah.
sharing my screen?
There's no, it's only when you're talking that you're sharing it.
Oh.
But maybe I can click on you. I can click on you. Never mind.
Okay.
Okay. So P with the hat is 0.475, and that's right because we get that right. And the standard deviation. But you can't double click on the p-value?
No, when I double click it, it shows me the that. And I don't know how to get rid of that now that it's open.
Okay,
I just keep messing it up. I don't know what that means.
yeah. Okay, so maybe she typed in just 0.0 and maybe she needed 3 decimals. I don't know. But let me try it. Let me go in. And then what other question did we miss? Okay, I think the rest, I'm going to go ahead and send that line just for fun and see what we get.
Okay.
Okay, 1 is good, 2 is good, 3 is good, 4 is good, 5 is good, 6 is good. We still miss 7.
Hmm.
And we missed 15, 16, and 17.
We
So
missed
we're-
17?
Uh-huh. No,
Was
we
that-
didn't miss 17 or 18. We did miss 15 and 16.
All right.
So we missed 7, 15, and 16.
All right. Let's go back and look at 7 real quick.
Okay, hang on. I gotta go to the bathroom really fast. I'll
All
be right back, okay?
All
Hang
right.
on.
Can you do me the favor and tell Serena that I need her? No, you may not eat those. Well, I just need to know what she's doing. Ask her what she's doing.
She's sleeping.
Okay.
Oh my, what a steal. Oh, jumped right over him.
Okay, I'm back. Sorry.
All right. Let's start.
With number 7.
Let's start with number 4 again and make sure we have all those right.
Okay.
I mean, work my way through it so I know what I'm putting in is correct.
Right.
Okay, number 4. Let me go back over here to my this thing. Okay, number 4.
N is equal to 100. P is equal to 0.25 and P with the thing over the value. See, this is what I don't understand. I always thought P with the hat is always equal to P.
Not always.
Apparently not. But how do we know?
I don't know.
That's why it drives me nuts.
All right.
The mean
so number
of P is always equal to P, I guess. The mean of P is always equal to P.
Right. Right.
Okay. But P is not a probability, or is it?
I don't think so.
Yeah, that's what I don't think so either. Okay. So what we're going to do is we're going to go
We're gonna
in
start
here.
at question number 6. Let's start at question number 6.
Okay.
N. A random sample is 60 people, so N is 60. On trial for first-degree murder was taken. Of these 45,
Mhm.
the defendants were found guilty. Now, is 45 P or is 45 X?
45 is X and 60 is N,
And so P
is my understanding,
with a hat
P-
equals 45 over 60.
which is 0.75. So now what I'm wondering, can you
Okay.
go into that tablet thing that you're using? What do they call that? I need to pull that up too.
It's called data analysis.
Yeah. Can you pull
Okay.
that up and put in the
X
those numbers?
is 45. N is 60. A confidence level of 95. That gives us our z-score of 0.845. And our P with a hat at 0.75, which is correct.
Okay. And so what are we asking in this question here?
And it gives me those confidence intervals, which were correct, number 8 and 9.
Okay, yeah, because we had 8 and 9 right, but the margin of error is what we're not knowing how to do.
So my thing on margin of error is, I'm going to do it by good old-fashioned pencil here and see if I can get it again.
Those margin of error questions I get wrong all the time. So there's something I don't understand about margin of error. I've got them wrong the whole time through. So there's something I'm not getting. It says the formula for margin of error is M equals Z times P 1 minus P over N. And I guess in this case, P is not, isn't P different than the P with the hat? Or no? This is not different.
They don't give me a different number,
They
so I
don't.
don't know what else to use.
Okay, and on your thing here, does it say the P and the P with the hat? It doesn't anywhere, does it?
Mm-mm.
Yeah, it does. It gives us the P with the hat.
At
0.75.
0.75.
Okay. But then look down there, the null hypothesis P equals 0.7.
Okay.
So do we use P with the hat or P to find the margin of error? It says we use P, not P with the hat.
Okay.
So what if we put 0.7? So we do
Instead of 0.75, we try 0.7. Okay.
0.7 and then 1 minus 0.7 over what's N? N is 60, right?
Yep.
Oh, but it does times our z-score, which is 0.845, right?
Yep.
But we do the square root. Did we forget to do the square root
No.
before?
No.
Let's see. .21.
Okay, so that gives me a different answer because we used a different P.
So we got M is 0.0. Oh wait, I got to do the square root. So it's 0.054. Is that what you got?
I got 0.051.
You got 0.051.
Mm-hmm.
Okay, let me try it again. 0.7. Let's see. 1 minus 0.7. Let's see. Okay, times 0.7 equals divided by 60 square root is 7.74 times 0.845 equals, I got something way different.
All right. So 1 minus, oh, clear my thing. 1 minus 0.7
Equals 0.3
times 0.7 is 0.21. Divided by 60
is
0.0035.
And then square root it.
Square root that. Okay, now times it by 0.845.
Okay.
0.04999.
.0499.
Yeah.
Round it would be
0.05.
0.05. Yeah. Can you hear my kids fighting?
Yeah, it's I was gonna say it's entertaining, except that I'm so sad.
I know. Che! Okay, you guys, I'm on the computer. You need to quit fighting. Jason, take off his shirt. Oh my goodness. Okay.
Yeah, 0.05.
Okay.
That's what I'm gonna say.
Okay.
All right.
But stop it. Stop it. Go clean the basement. Go clean the basement. Go clean the basement. phone right now. Give me your phone right now. Right now, give me your phone. You have 10 seconds. 1, 2, I'm on the phone. Give me your phone. Hang on just a second, Michelle. Go do
Uh-huh.
your stuff.
Why aren't you taking my
I don't
chase
want to hear
phone?
any
Why
more
aren't you taking my
fighting.
chase phone?
Go downstairs right now. You have 10 seconds. 1,
You're not doing it.
3, 4. Go downstairs. But if he doesn't want to take it off, I'll buy you a new one. Get downstairs. Go now. I'm busy doing homework. I don't want to see you again. Tired of the fighting. Sorry, I'm losing my crap.
Yeah, right. I get it.
Okay. All right.
All right. So number 7, we put in 0.05.
Okay, yep.
Okay. Then we're gonna change. I'm gonna change this in my notes. Okay. Number 15. Oh, number 15. Let's see.
Hang on, Michelle. Sorry.
Okay.
Okay, Jay. Go downstairs right now. Downstairs. Now.
Totally. I take
Come up here again. You're not going. Tell her you're not going. Get downstairs now. Right now. Stop it. Okay, tell her to chill out.
Jay will have to call you.
Go through those clothes like I asked
I
you.
told you I will.
Right now.
Where's my shirt, Jason? Where is it?
Gary,
I'm going upstairs.
I already told you I would take it
I
out.
need my shirt.
This is ridiculous. Sorry, Michelle.
I'm so sorry.
My kids.
It's in my room, dude.
It must be a very important shirt. That's all I have to say.
They're just in it. They're in the fight.
Yes, and neither can give it up.
No, and it's just.
I
Ugh.
really told him I'd give him my shirt. And he's like, no, right now.
Okay.
now.
So we're going into. We got the p-value right. I just
On
don't
number
understand
14?
why that's wrong. Yeah.
Yeah, we got the p-value. The p with the hat is 0.475. We got that right.
And that's when you put it in that thing, it comes up with our test statistic, which is the
D. Negative 4.392. Okay. I don't know why it's wrong. Unless we want to find the z-score longhand. Do we want to try and do it with our calculators?
we can.
Okay, let me look at that formula.
I don't even know.
That is z equals the sample p minus p over the standard deviation. Do they give me the standard deviation here? Oh yes, 0.0512.
Mm-hmm.
Let me try that.
The biggest problem that I have with all this is like we know that we get them wrong, and so therefore we can go back and look for a way to do it. But when I do the test, is like I don't know.
Exactly. Exactly.
This is what's so frustrating to me about all this stuff, and I know I got to get over that, but I can't. Just,
I know, it's hard.
it is.
All right. So our P, our sample P, our P is 0.475. What's our other one? 0.475. 0.475
Okay,
minus
so
P.
this is where I'm wondering. Okay. Okay. So in the reading, it talks about the water
Okay.
a little bit. So, okay, if we go in here, the two requirements required to conduct this hypothesis. So the following questions will guide you through the process. Okay. Test if the
Okay.
water quality has decreased. You use the standard deviation of, or the test, that weird symbol alpha 0.05 for this test. Okay. We know that n is equal to 40 and we know that x is equal to 19. And that's kind of the information that we know right now, right? Okay, then it says use this information. So what is the proportion of the observed indicators that suggest the good health? Express your decimal as a percentage. And we did that in the 0.47, whatever, what it was that we.
Right. That's the P with the hat.
Okay, so we got that. And then it says, the following questions will guide you through. The two requirements required to conduct this is MP is greater than or equal to 10 and N is whatever. Are these requirements satisfied? We already know that that's probably true. Yes, these requirements are satisfied. The null hypothesis test is P is equal to 0.6. What is the alternative hypothesis? In this sense, we want to know if it's greater than, if P is less than, if it's decreased, right? So that's exactly like this example here. And then it says, fill in the blanks to compute the z-score. Z is equal to P minus P. Okay? So over the
standard deviation.
Yeah. So P, the square root Z, or Z, or I'm sorry, P with that. I cannot believe my kids are being this disrespectful. I'm about ready to kill them. I'm sorry. Jathan James, you are not to talk to Che at all. At all. Until I'm off the phone. Then stop and fold the clothes that I've asked you to fold. Okay, so let's see. 19 over 40. How did they get 19?
Well, because that's their X.
Is that their X? Okay. So that's 0.475. Okay, so they got the Z because they did P minus P. P with the hat minus P.
How come their P with the hat equals 0?
I know, they don't put anything in there, huh? Because it should be equal to 0.475, huh?
Well, I think it should be 19 divided by 40.
Yeah, which is 0.475.
Okay, yeah.
That's what I don't know. So when they do that, oh my gosh. Oh my gosh, my kids. But where did they get the 0.60? What's the 0.60?
That's their null hypothesis, P equals 60, or 0.6.
Is it 0? Because so if we do that math right, 0.60.
Maybe it's not a 0. It's just parentheses now that I look at it closer. It says fill in the blanks. Number 18, is that what you're looking at?
Yeah.
Fill in the blanks to compute the z-score. What is the missing value? Oh, it's the P with the hat. So it's 0.475. Okay. That's right. So then 19 says the p-value will be the area under the normal curve to the left of z. Why will you only shade in the left tail? Because we want to know if it decreases, right? And how come their z-score is negative 1.614. Fine.
Because ours is exactly the same. Do you notice that we're doing the exact same problem? Except for our numbers are different.
Our numbers are a little bit different, but our
But our Z,
hypothesis
our
is the
P-
same. Our p value and our p with a hat is the same.
yeah, uh-huh.
Point 1.614 is the z-score, huh?
Okay, so I just want to do that by hand just to be sure that that's what we get. So we're going to do
Oh, it is.
Okay, and that is what I get by putting 0.474 in there. So their z-score is negative 1.614. So in our case, is the 60 the same? All of that would be the same then, right? So I'd be negative 1.647. And is that what it is when we put it in that tablet?
No. No, it's negative
It's not.
4.392.
But it should be negative, when we do it longhand, it should be negative 1.614.
Wait, my null hypothesis is different. Let me change that. Right, now do it. It says our z-score is negative 2.282.
You know what though? Okay, but we're asking if it's decreased, so we're only doing one side of that.
Oh, yeah.
So divide
So
that
that
by
would be
2.
our p-value.
Oh yeah, you're right.
So my x is 38, my n is 80, my confidence level is 95. Is that true? They didn't tell us, I don't think. My null hypothesis is 0.6.
Mm-hmm.
Type of test is less than.
You got to put it in the normal probability too, it says here.
Well, but I gotta figure out what my z-score is first, right?
Well, isn't our z-score equal to negative 1.614 because it's exactly the same? It's
Yes, it is, except in
0.4.
this program, it doesn't tell me that. In this program, it tells me it's negative 2.282.
I know.
I'm wondering
So
why my program is not working.
yeah, I wonder why too. Maybe you should restart it. Maybe.
Let me close. Do I want to save changes?
Because if you do it
No.
longhand, we get the z-score of, but that's our z-score, not our test statistic. That's our z-score.
Isn't that our test statistic?
Is a z-score a test statistic?
I think so.
I guess it is, isn't it? Yeah, isn't a z-score
what we're
and a
looking for.
t-score? Yeah.
Mm-hmm.
So our z-score should be negative 1.614. And then we put it in the applet, the normal
Right.
applet.
And I have that right here. So if I put in my z-score, right here, negative 1.614.
Mm-hmm.
then it's 0.0533.
Okay, and that's what they say here.
So number 16 on our quiz
Mm-hmm.
would be 0.0533.
So
If that is our z-score.
yeah, and number 16 would be 0.053. And I'm only going off of the reading, how they did it. So, and then the rest we got right after that.
Okay.
Okay, so try those, do your quiz, and then I have one more thing. I haven't done my quiz, redone my quiz yet.
Okay. Okay, this is the one I put in here, and this is the one I put in here. Okay, I have to write down my answer so I remember what I'm doing.
That's me. That's me too.
Okay. So let me go back to my quiz. And let me see what I'm typing in here. Number 15, I'm going to say is negative 1.614. And number 16, I'm saying is
It's a negative. It's negative 1.614.
Yeah.
Okay.
And then number 16 is positive 0.0533.
5.0533.
0.0533. Okay.
Yeah, that's what I wrote down.
And then
But I think if you round it, it'll be 0.053.
oh yeah, you're right. Okay.
Okay.
And let me make sure I change number 7. Number 7, my margin of error, we decided I was going to put 0.05. I don't know why. Oh yeah. Okay.
Because we did that weird thing, but I don't remember what we even did to figure it out. Do you now?
Nope.
I have no idea. Oh, we did that problem
Yeah.
in here. That's what we did. Okay.
Am I still sharing my screen? Can you see?
Yep. Yep, I can see.
I got 16 out of 19. So what did I miss?
We missed all 3 again.
16 I got wrong. 15 I got wrong. And 7 I got wrong. Okay, so I have a philosophy on 15 and 16.
Okay.
Let me go back and restart my quiz again. Okay.
Okay.
All right. I think that number 15 and 16. So over here on this, oh, where did it go? Did I close it? Desktop 2. Right here. When I put in this, the 0.60, it gives me this z-score, negative 2.282.
When you put in what?
When I put in these scores right here, it gives me this negative 2.282
For your T, for your test statistic.
for my z, yeah.
What 2
So
are you
that's what
talking
I'm
about?
going to put for my answer.
Okay,
Huh?
what 2 are you talking about? 0.053 and negative 164? Negative 1.164? 614? What's
I'm talking about number 15,
uh-huh.
and I put in my x is 38, and my n is 80,
Okay, yeah.
and my null
Didn't you do
hypothesis
that
is
before?
60. Yeah, but we took the z-score that we found in the reading instead.
Oh, okay.
So this time I'm going to take this one, negative 2.28.
Okay. You're gonna do
And then
on number 7. You're gonna do negative 2.28. On number 15, I mean.
negative 0.28. No, not number 8. Don't put that in number 7. Number 7, negative 2.28. Negative 2.282.
Okay.
Okay.
And that show me your tablet. What you're doing again,
Here?
just to be sure that I understand. Yeah. No,
Okay, so I put,
I don't see your tablet at all for some reason. I only see your quiz.
you don't see this one right here?
I'm not sure why. Uh-uh.
Let me see.
I don't know why. I see your normal probability applet now.
Okay. Now do you see this?
I only see the normal probability applet.
I must be going slow. Okay. Do you see my quiz?
Now I see me. Oh, now I see your quiz down there. Okay, now just go. Go to your next thing.
Okay. So this one. Do you see this one?
Okay. I just
So I have
see your quiz.
Oh.
Okay, maybe I just need to pull it up myself. I just have to go in and find it to pull it up in the reading.
Okay.
Let me do that. Oh my gosh. How did I get to the homework? Is this quiz 16? It's quiz 16, right? Group quiz 16, group quiz meeting, right?
No, it's 17, isn't it?
Oh yeah, let's see. Okay. Okay, yeah, here it is. Okay. Let me pull it up from here, this reading, because I haven't downloaded it. I haven't saved it on my screen yet. Okay, so when you put that in, you get those two at the negative 2.282. And then what do you get for number 16? Because what's the question there?
So number 16 says, what is the p-value for this test? So when I looked at my analysis right there, it says p-value 0.011.
Uh-huh.
And when I plugged it into my applet, when I marked that I just wanted the lower score, it gave me the 0.011 as well.
Okay, so number 16 is 0.011, which so we're going to try those on those. And number 7, margin of error.
know.
That one I get wrong every stinking time.
Yeah.
I don't understand how to find the margin of error. I guess I need to get with the. What I don't understand is why it went into +4 confidence interval, when we didn't even use any of that in this.
Yeah. I used it once. I'm going to fill in all my other answers, and then I'm going back to number 7.
Okay.
On number 13, can you look at 13 real quick?
Yeah, 13.
Is it true?
Am I on the? Hang on, I'm on the wrong thing here. Oh, you know what? I X'd out of it and opened a new one. Let's see. What the heck was I thinking? Because now I can't look at my answers.
Hey, Mommy,
What, honey?
can we go to Box and ask them if they want to have a water war?
Can you give me a little bit to finish this up, and then I
Can I
can
call
call them?
Can I call her?
Not right now. Give me a second, okay?
And Mom, I thought about it. And the squirt gun that they got me, that was supposed to be my birthday in January. It was better that they give it to me now.
Of course it is.
It's summer.
Brilliant, huh?
If they gave it to me in January, my birthday, then why?
You can't play with it in January, can you?
I can't pull up my quiz.
Okay.
Sorry. Because I opened this other one already. So you're going to have to help me once we get there.
All right.
School's hard enough when you're on your own, but when your kids are home, it's 10 times worse.
It is so hard.
And last year I wrote that I should never ever take this semester again. Did I listen? No.
Mm-mm.
I did not listen to myself. And you have camp next week. Is it next week?
Yes. And I'm in charge of like scheduling it. So I scheduled it, like clear in December. And so I didn't even think about this class. And
I know. It's just.
so now
nuts.
everybody's like, why did you schedule that at the same time? I'm
Okay,
sorry.
I was finally able to pull up your quiz. And you were asking about number 13, and it was
Uh-huh. I think it's true.
True. Yep.
Okay.
Okay, did you submit all your other stuff then?
Not yet. I was waiting to tell you the answers. Are you good?
Yep.
Oh, number
Just-
7. I have to figure out number 7.
Yeah, because that one I don't even know. We can determine the sample size we need to obtain a desired margin of error using this formula. N equals Z over M squared.
That's the second thing, right? So my Z is 0.845 divided by
2m. But what is m?
We don't know M. We can't use that one.
We can
We have to
determine the
use-
sample size we need to obtain a desired margin error using the formula n equals z times m squared. I don't even. Well, an m is, did we square root it? Because m is equal to z times p times 1 minus p over n, but did we square root it?
Mm-hmm. Yes,
And
I square rooted it.
Okay, what's the margin of error that we're using there in number 7?
Well, that's what we're trying to find out.
The margin of error. What's the
The Z
the
score.
p? The p. What p are we using?
0.7.
Oh yeah, because we used point something else, didn't we?
75.
And we got it wrong then too.
Yep. Well, Lupita said we got it wrong.
Did we have 0.047 before? Oh wait, times z. Oh yeah. Did we have 0.4 in the other? Okay, you did something else last time, right? Let's see, number 7. I did. Oh, well, that's different. Try 0.047.
Did you get it right with 0.047?
I don't know. I didn't try it. But that's what I'm getting when I times this out, times our z score. It's
That's if we
0.75.
use the 0.75, right?
Mm-hmm.
'Cause when
That's
we
what I
do the-
use 0.75.
Yeah.
Yeah.
Because when we used 0.7, we got the
It-
0.05, and that was wrong.
Yeah.
But I think Lupita said that the 0.047 was wrong.
0.36 was wrong too, which I don't know how we got that, but whatever that. Oh, that's because I minused it. Okay, so 0.75. I'm gonna try that again. 1 minus 0.75. Now I got something completely different. 0.07. Two.
Still like 15 over.
Now I got another different answer.
I'm just going to put 0.047 and see what I get. Because that's what happens when I use the 75.
Okay, that's what I got the first time, and now I'm redoing it, and it's wrong. So but it keeps getting wrong. Okay, you're going to use point what there? I'm going to write it
Well,
down.
I'm.
0.047.
Oh,
Didn't we
I'm
do that before?
Yes.
Didn't we do that before?
Yes.
And we got it wrong.
Yes.
Jay, go downstairs and clean the basement. Cause you messed it up, dude. Is it clean from you guys playing in it yesterday? Okay. I'm trying to leave and go to my mom's so my mom can help me with my kids.
That would be nice.
Because I have to worry about my practicum class too.
Yeah. Where's your mom live?
In Logan.
Mm-hmm.
And then they won't fight so much. I keep getting 0.47 too, 0.47.
Okay. So if I do the 0.75, it's that. But if I do the 0.7, like we
Mhm.
did over like on number 13-ish,
Mm-hmm. Did I?
then we get the
Did we try the 0.7?
Yeah, and that's what we just turned into 0.05, and it was wrong
Yeah.
as well.
And then I took the margin of error. I subtracted it.
Hmm.
And I got
Subtracted it from what?
44.36 from the lower bond, remember?
Oh, yeah. Yeah. Maybe that's what she said was wrong. Wait a second.
No, it was 0.047 that was wrong. Because I went back in and changed it.
And then your 44.36 is, you haven't put that one in yet.
No, I did. I put the 44.36 in and got it wrong.
That was wrong. Okay.
Mhm.
So all three of our answers are wrong.
Yep, because we don't know how to do the stupid problem,
Yep.
even though it says that we should.
Yep.
Even though it's telling us how to do it.
Yeah. I don't know.
Then it says right here, if we have a prior estimate for P, we can plug this value into the equation above to compute the sample size required to obtain our desired margin of error. N equals Z times Z over M squared times P times 1 minus P, where Z is determined by your confidence level, M is your desired margin of error, and P star is an estimate of the true proportion of success. If no prior estimate for P is available, we can use the following formula to compute our sample size. But see that
But that's figuring out sample size.
mm-hmm. But it says if you want to find the sample size required to get a margin of error of M equals 0.03 with confidence. So it's showing us how to do it backwards.
Mm-hmm. That's if you know your margin of error.
Okay, I see what it's saying. It's saying if we can find the P for the margin of error. I have no clue. Margin of error. And I'm pretty sure I got all those wrong on this last test. Margin of error questions.
Right.
Because what is the margin of error?
I have no idea.
Okay, well, did you try those last two? Did you get them right?
I haven't tried yet. I'm getting ready to submit.
Either.
One time when I was calculating this, I came up with a 0.051 for number 7. But I'm wondering if I just typed it in wrong.
Yeah. Do
That
you want
one
to try
time.
0.51? You can't. It can't hurt you.
That's true. It can't hurt me. Point
It can't.
051.
Because at this point, I don't have any idea what to even do.
Okay. So I think all of my answers are saved. I'm going to come down here. Submit my quiz. Do I really want to submit my quiz? Yes. Oh, yes, I do. Nope, I got it wrong.
The last three again.
Number 7 I got wrong. And everything else I got right.
Okay, so you got those right.
Yep.
I'm going through and I'm going to put in these numbers again. Number 6 is 0.75. You know, it'd be fine if I had hours and hours to sit here and just try to figure things out. I maybe could learn something, but now I'm just like, I don't know. So number 7, we still don't know.
Right.
Well, what was our number before in our higher bound? Let's see.
The lower bound is 0.64 and the higher is 0.860.
0.64? On number 7? Oh, yeah. The input of the lower bound. Maybe I did that wrong because why would I get that? Okay, so I'm going to minus. Let's see. I had to have done that one wrong because 1 minus 7 1 minus 0.7 equals 0.3 times 0.7 equals 0.21. Divided by 60 equals 0.0035 squared rooted times 0.845 equals 0.049. I'm going to take that 0.049.
Okay.
And it's actually 0.05. And I'm going to subtract it from our lower bond. And I'm going to put 0.59.
Okay.
Because then that's taking the higher from the lower on that. I don't know if it's right, but that's what I'm going to do. And then I'm going to do input the lower bond on number 8 is 0.64. And the higher bond on number 9 is 0.86. And then if you decrease the sample size, that's increase, right?
Decrease. Number 10, decrease.
Okay.
11 is 20.
11 is 20. Okay.
12 is 100.
12 is 100, and we got that right. Okay, so we understand those, so that's good. My test is not saving.
Sometimes it takes a minute.
And then number 13 is
True.
true. 14 is
0.475.
what is it? 0.75?
0.475.
Okay, yeah, that's that one. 0.475. Statistic you said is negative 2282. Is that right?
Negative 2.282.
Negative 2.282. And that's because we stuck that number in that applet thing and got those.
Yep.
And then we got 0.011
Yep.
for the p-value
Yes.
in 16. And then in 17, we got reject the null.
Mm-hmm.
And it's D, right?
D. Yep.
Okay. Let me go back and see if 12 got a number in it because it said it's blank. 12 has a number. Okay. I'm going to submit my quiz. I still got number 7 wrong, of course.
Yeah, I don't know what to do about that.
And I got number 18 wrong.
What?
Was
D?
D? It was
Yeah.
supposed to be D, huh? And I put C. Why did I do
Oh.
that?
You
It
probably
was a
didn't
misstep.
scroll down or something.
Yeah. Oh well, it is what it is. Oh, so we missed 2. What was the other one I missed? Oh yeah.
Number
yeah.
7.
Yeah, that's right. Well, and even in the homework quiz, what did I do with that? I missed the margin of error in there too, I think, if I remember right. I'm trying to find it. What do I do with it? I don't know what I did with my homework quiz. I guess I'll look at it right here because I usually print it out so I can look at it
Right.
because it helps me. For 16. Okay, so I missed on the homework
Mm-hmm.
before this on lesson 16. I missed your little brother has a career battling average of 0.233. You want to determine the probability that he will have a batting average of over 0.25 next season. Will he be at the up to bat 40 times? Are the conditions met? So the sample proportion will be approximately normal. And I got that one wrong. But it could be D on that one. So I think I understand that one. Okay, and then, because I think I did the math wrong. Okay, and then what is the difference between a bar chart and histogram? Are those the only 2 I missed? No, I missed 3.
The histogram
Oh, and
just
research.
numbers.
You what?
The histogram does numbers, the numerical, and the bar chart does categorical.
Okay, so each column of a bar chart represents a group defined by a categorical variable, and each column of a histogram represents a group defined by a quantitative.
Yes.
Okay, that's what I got. I just got those screwed up. And then researchers published a study in which they considered the incidence among the elderly various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of N is equal to 750 adults over 65 in the study suffer from one or more conditions. Give your answers correctly. And what I did is I took 320 and put it over 750, but I got it wrong. I'm not sure. So how would you calculate the probability that fewer than 320 out of N equals 750 adults over 65? Where before they did it and they found 45%, so 0.45 of adults over 65. I don't understand that one.
Can you share it on your screen with me?
Share my screen? Is that what
Yeah.
you're asking?
Yeah.
Okay, let's see. Okay, so can you see my screen now?
Kind of. You got to click on it though.
I'm gonna.
Okay.
Do you see my test?
Yes, it's very small.
Okay, hang on just a second. Let me pull it up.
Oh, there.
Let
Okay.
me maximize it. Can you see it now?
Yes. What number are we doing? Number 10?
I'm
No.
gonna eat these, Mom, okay?
No, don't eat those. Those are for girls' camp, honey.
I am so hungry.
I know. So what number are we doing?
Number 10.
Okay.
Please. Please, Mommy. Hey, I know how to bowl my Superman cereal.
So researchers published a study in which they considered the incidence among the elderly of various mental health conditions
Oh, my cereal, Mom.
such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one
Where's
or
my
more.
cereal?
Okay.
No, Mom.
Okay,
My
read it,
Superman
Joaquin.
cereal.
Where is your Superman cereal?
I'm asking you.
Check the back of the car if it hasn't been brought in. Okay. Sorry. Superman cereal is important.
Yeah, I know. It doesn't sound as important as my sunshine yet. though.
Well, you never know.
I'm just kidding.
Okay. So read it to me again. They're
Okay.
gonna do this testing for people in the
Yes.
United States. 45%
Yes,
of
and they-
adults suffer.
Over 65 suffer from one or more of the conditions considered in this study.
Okay.
Calculate the probability that fewer than 320 Out of the sample size of 750 adults over 65 in the study suffer from one or more of the conditions under considerations. Give your answers accurate to 3 decimals. And do you see my quiz right there, number 10?
Yeah. Yeah.
Okay, so you see that.
Okay. So I'm going to say that N is 750.
Yes,
And I'm going to say that X is 320.
that's right. Yep.
Okay. Then I'm going to come back over to this dumb thing over here. And I'm going to say X is 320.
Okay.
N is 750.
Mhm.
My confidence level is 0.95. And my null hypothesis, did it say anything like that? 45.
Well, basically, the hypothesis is that
45%.
300 and, yeah, let's see, calculate the probability that fewer, so less than 320, so it's going to be less than the 45%. If that makes sense.
So my null hypothesis is 0.45.
Okay, yep, that's what
So
I would put.
So this is going to give me a Z value. I don't know. Let's just write down all this stuff. My hat,
Okay.
my P with a hat is 0.427.
Is what?
0.427.
427?
Uh-huh.
Okay, that's what I put.
My Z
Okay.
score is negative 1.284.
Negative 1.284. Okay.
My P value
Okay.
is 0.099.
Okay.
So
So then, so are you going to put your p-value in, or z score in, negative 1.284 in the output, and then just look at the bottom half, probably, maybe. No?
my Z score is negative 1.284. And that
Yep.
does give me the area of 0.0996. Okay?
Okay, so we just want to shade the less than, though, side.
Yes. Yep.
And we get what?
0.099.
Still?
Yes.
So it must be I need to try 0.099 then, here.
Well, mine says 0.0996. So if you're going to round it up,
Yeah, that's what's hard. So it's 10.
yeah. So I would say 0.1. Which is, and then if you make that a percentage or a, what is the probability? What is the question?
It says, what is your probability? Calculate the probability. So you're right. We would put it in the applet.
And it would be 0.1.
It's 0.1 because we round up the first 0 to 1. That's it.
And then, but is probability supposed to be a decimal or is it supposed to be a percentage?
It says decimal.
Okay. I would say 0.1.
0.1. Okay. All right. That's what I do there probably on the homework. And these others, I just got messed up in my, those should be easy to
Okay.
rectify, I think. Okay.
Yeah.
I
Well,
should
hope
try
it's
it.
0.1. It might be 0.099. I don't know. Try it and see.
Yeah. Well, I'll try it, and if it is wrong, I'll let you know, because
Okay.
if I can get this computer to work. Okay. And then, yeah. Okay.
Okay, now for
That
our
number was number 10.
okay.
Oh, yeah. Yeah. Okay, so
For our
To
design
our-
the study,
yes.
I think that we need to meet as a group again, like Friday morning,
Yes.
and fill out this paper.
Okay. Yeah, I think so too, because it's not really fair if we don't all meet, I don't think.
Yeah. Because like the examples that he gives are there 1,000 chips in every bag of Chips Ahoy? Are paper towels stronger? Are these paper towels stronger than these paper towels? Is there a difference in prices at the bookstore? Are men or women more likely to walk on the grass if they are walking behind someone who walks on the grass? Well, that's too complicated for me.
I like the 1,000 chips in the every bag.
Yeah,
That
I'm
one
not gonna,
sounds super easy.
I'm not gonna count 30,000 chocolate chips.
Yeah. We could just do a bag of chocolate chips at Costco.
We could.
Does everybody have
Um,
a Costco card though?
I can arrange for my neighbor to pick me some up. Yes.
Or we could get some from Sam's Club. Do you have a Sam's Club card?
No, I don't. It's okay.
Okay.
But I have a neighbor who
Okay.
says, anytime you need something from Sam's Club, let me know.
Okay, so yeah, so 2 bags of
Um,
chocolate chips.
I'm thinking that,
They're cheap
yeah.
and they're easy. I could buy y'all a bag and just get. Well, I couldn't drive it up to Abby, but I could drive them over to you.
Yep. So I'm just thinking we need something that gives us a statistic, and then we compare our things to it. And it's
Yeah.
probably easier if I buy it and count it than if I go watch somebody and count it.
Amen. I'm with you. I don't have time to watch people.
So
So
on this, I think it would be way cool to do like the categorical or the 2 sample paired, but that is way more time
More
than I want to put into it.
I agree. I'm with you on that 100%. I have very limited time. So I've got to get done with I've got to get marketing on my workshop, and all my lesson plans have to be turned in this week. Plus I have another thing I have to resubmit. So I'm like really swamped this week. That's
So
why
what
I'm going
time
to
do you
Logan.
think you could meet on Friday?
We could do noon again, or 10, or 9. I can do early in the morning and do whatever.
Okay.
Do you want to contact Abby and Lupita and find out?
Okay. I don't have
I
Lupita's
think
contact information.
I don't either. I don't either. So maybe I actually have her email though. So I could here, let me just write her right now.
Can you just do a group email to all of us?
Yeah, I'll just do it. Yep, I'll just do it because I
Okay.
remember I have them all. Okay. So I kind of like the chocolate chip idea because it sounds easy. But all right, we'll ask them.
Well, I think that
Okay.
let me see. How many chocolate chips are in a chocolate chip bag? Then I can have my children count them.
I know. See, I can have mine count them too. My husband would even do it because they love me and don't want me to be insane. Well, sometimes. All of them, but maybe one. I think my son might enjoy that I'm insane. I think. Okay, so okay. Hi. We need to meet on Friday, if at all possible. Discuss our design study.
Because it's due Friday.
Michelle and I are both super flexible. Are you?
Yep.
On Friday. However, if we can meet in the morning, that might work best.
Mm-hmm.
Okay.
What if we counted starbursts because they're the same size? No matter what
Okay.
kind of starburst you got. You know what I mean?
Yep. Or even gummy bears too. I mean, any of those. If you can get to Sam's Club or Costco, we could get those big bags. They're cheap, is what I'm thinking. We'd have a lot of samples. You know what I'm saying? I don't
Right.
know that that matters. I don't know that that matters. Okay, so hi, we need to meet on Friday if at all possible to discuss our design study because it is due Friday. Michelle and I are both super flexible on Friday. However, if we can meet in the morning, that might work best. What about 9 a.m.? Will that work? If not, we could do 12:30. Michelle and I are thinking maybe counting something for our study because of time, summer, and kids. What do you guys think?
Perfect.
That okay?
Yep.
Okay. I will send this to everyone.
Okay.
Okay.
Color
it's been-
distribution of one 14-ounce bag of starbursts. Let's see what that says. Hmm. Didn't give me what I thought I wanted. Okay, we'll see what they say back.
Okay, yeah. What, Shay? It is stuck. Washing.
What do you mean?
Is it washing? Is it in the wash cycle?
Yeah.
Okay, so push the number back in, push the thing back in and turn it up to like just turn it up to to the next level up. Yeah, my stupid washer keeps getting stuck.
Oh no.
Yeah, but it's all good. It's like the least of my worries. Okay.
Stuck, but it still washes.
Yeah, exactly.
Right? I mean, come on.
Yeah, that's fine. I can live with that.
I
Okay, so yeah, let's just see what they say back, and I guess, yeah, that's it. I guess we'll talk about it on Friday.
okay.
So, and I guess I'll probably be in Logan. Hopefully, I'm hoping to leave today,
Good.
so my mom can help me with my kids. All right. Well, have a good day. Good luck with everything.
you.
Is it next
Thank
week? You said you're going to girls' camp.
Yeah, Tuesday. So if I get this this design thing done on Friday, and then I can meet with you guys on Monday,
Yeah.
but I won't be able to meet on Wednesday. I don't think. I think I'll be able to turn in my homework while I'm at camp, but I don't think I can meet. So,
Yeah. Understand. Yeah, because that's hard. Because it takes us like 2-3 hours to talk and
I
figure
know.
our stuff.
I know. I'm like, "Wah!"
And then I get.
Awesome. All right. Good luck.
All right, you too. Take
Thank
care.
you.
Okay,
Okay. Bye bye.